Let us see one more simple example to sum up the positive numbers and end the sum as soon as the user enters the negative number. Here is the program. So initially the entry is made equal to 0 and the sum is made equal to 0. That means we are initializing both the variables as 0. We are giving the instruction for the user with the print statement, enter numbers to sum, negative number ends the list. Okay, again the while loop reserved keyword begins the while statement. So we are checking the entry. If entry is greater than or equal to 0, then entry is equal to get the user input, means the value for the entry from the user. Okay. Again we are checking if the user enters the positive value, only then do the summation operation, sum is equal to sum plus entry. If the user enters negative number, then this if condition becomes false. When this if condition becomes false, the body of the if statement will not be evaluated. Once the body of the if statement becomes negative, the entered negative value will be passed again to the while condition. Okay, so what happens when the body of this if condition becomes false? The if condition will not be evaluated, means the body of the if statement will not be evaluated. So once this evaluation has been skipped because of the false condition, then the variable which is inside the while loop will be passed again to the condition of the while statement. So since we have entered negative value, entry will be checked here. Okay, since we have entered negative value is greater than or equal to 0, obviously no, the condition becomes false and the loop will come out of the the program flow or the control flow will come out of the loop, means it will exit the loop. So once again let us look at the logic. The initialization of the entry to 0 coupled with the condition entry greater than or equal to 0 of the while guarantees that the program will execute the body of the while loop at least once. Okay, because we are using entry is greater than or equal to 0, hence the while loop body will execute at least for once. The if statement ensures that the program will not add a negative entry to sum. It will once again check for the positive numbers. It will add only if the entered value is positive. When the user enters negative value, the executing program will not update the sum variable. Okay, because the if condition becomes false, then the body of the if statement will not be evaluated. So because of this negative entry, the condition of the while will no longer be true, because if condition becomes false, body of the if statement has not been evaluated and the entry is passed to the while condition. Okay, the entered variable value, that is negative value, will be passed to the while condition and the condition no longer be true because of the negative value. When the condition becomes false, the control flow will come out of the loop. So this is how the program flow works. Finally, the print statement, which is not the part of the while loop, will be executed, because this print statement is just below the while loop. Okay, it is the normal program code. Okay, that's what I mean to say. It is the normal program code, not the control flow code part. It is not the part of the control flow. So it is a normal program code. Let us run this code. Let us enter the positive numbers, for example 5, and once again 4, again 5, 5 plus 5 10 plus 4 14. Let us enter the negative value to terminate the loop, -4. So look at here, the result is 14. As soon as we enter the negative value, the if condition becomes false, and the entry, the recent value of the entry is -4. So this entry is passed to the while condition, that is entry. -4 is greater than or equal to 0? No, obviously, right? Hence this condition, while loop condition, becomes false. Hence the loop will terminate and the program flow execute the final print statement. In Python, sometimes it is convenient to use a simple value as conditional expression in an if or while statement. Python interprets the integer value 0 and floating point value 0.0 both as false. Okay, even if we use 0 or 0.0, both will be considered as false. All other integer and floating point values, both positive and negative, are considered as true. We have already seen this. This means if we look at the following code, like x is equal to int, get the integer from the user using the input statement, while x, print x is equal to x minus 1. And this program is equivalent to, or this condition is equivalent to, x is not equal to 0, print x is equal to x minus 1, decrement the value of x or the variable x. Here we are printing the value of x only if x is non-zero, and here once again we are printing x only if x is non-zero. But here there is no proper condition, means proper way of expressing the condition. We are just using x, but here we have written the correct way of the expression. So x is not equal to 0. So let us see what happens here by selecting this code and running using F9. We need to enter the value for x. Let us enter x as 5. When we enter x is equal to 5, look at here. Initially the value of x is equal to 5, that is either the positive or negative values, the condition becomes true. Okay, Python interprets both positive and negative as true expression. Okay, so initially the value is 5 is true, print 5, again decrement the value, 5 is equal to 5 minus 1, x is equal to x minus 1 means 5 minus 1, again 4, x is assigned as 4, 4 is checked, 4 is positive, so true, 4 minus 1 3 is true, Again 3 minus 1, 2, 2 is true, 2 minus 1, 1 is true, and 1 minus 1 finally 0. While 0, the condition becomes false. Whether it is 0 or 0.0, whether 0 or 0.0, floating point value 0.0, the interpreter will treat it as an false. Okay, when the condition becomes false, the loop will terminate. So this is how the program works. Let us run this code snippet and see what happens. Let us once again enter 5. So once again 5 is not equal to 0. Yes, 5 is not equal to 0. 5, and then decrement the value of 5. 4 is going to be the condition. 4 is not equal to 0. Yes, the condition is true. Again decrement the value. 3 is not equal to 0. Again decrement. 2 is not equal to 0. Again decrement. 1 is not equal to 0. Again decrement, and 0 is not equal to 0. So 0 is not equal to 0. What happens? 0 is equal to 0, right? But 0 is not equal to 0 means condition becomes false. If the condition becomes false, the control flow will terminate the loop. But which one is better to use? We can decide which one to use. So this type of complexity arises when we use floating point values like 0.0. So as we can see here, when we use the floating point numbers with the while loop, it is advised to use the less than or equal to or greater than or equal to instead of equality or not equality operators, because floating point numbers with the decimal fractions will not create an whole number with the exact values as we accept. Okay, so here you can see the problem, and once we go through the problem, you will come to know why we need to use less than or equal to or greater than or equal to instead of equality or non-equality operators in floating point numbers while using them in the iterations. So if we look at this program, here we are using x is equal to 0.0 as the initial value, and while x is not equal to 1.0, that is the final value, print x and increment x value by 0.1 and finally print the result as done. So let us run this code and see what happens. So look at here, the program is keep on running. So do you guess why? Because the program runs without stopping, because of the logic here is x is equal to x plus 0.1, x plus is equal to 0.1 for this statement. So this will not become 1.0 exactly unless all the fractional parts of x sum up to 1.0, but this type of calculation may not happen in the above program, means in this program. Hence the program runs continuously without stopping. So how to resolve it? As we said earlier, we can use the alternative expressions like lesser than or equal to or greater than or equal to instead of is equal to or not equal to in this condition, like x is not equal to 1.0 or x is equal to 1.0. Is x is not equal to 1.0 or is x is equal to 1.0. Suppose if we use x incrementation of the x as 0.125 instead of 0.1, then the total value after some iterations becomes 1.0 because of the exact quarter value, that is 0.125, because of the exact fractional value, that is 0.125. so look at the value 125. okay, so we know that 0.25 plus 0.25 plus 0.25, 4 times if we add, it becomes 1.00 exactly. So if you use that type of floating point numbers or such floating point numbers, then there may not be an ambiguity in running the while loop. So let us stop this code by using the stop icon. So look at here, the red icon, that is stop the current command. Okay, let us click on it. Okay, so manual interpret, that is keyboard interpret. Let us run this code, small code. Here instead of x is equal to x plus 0.1, we are using x is equal to x plus 0.125. Again x is not equal to 1.0, and here x is equal to 0.0. Let us run this code, control plus enter, and look at here the iterations, how it has been taken place. Look at here, 0.0 initial value, and in the second iteration 0.025, third iteration 0.25, and in the fourth iteration 0.375, and fifth 0.5, 0.675, 0.75, 0.875, and finally done. How many iterations? 1 2 3 4 5 6 7 8. After 8 iterations the program has written 1 and the condition has terminated after 8 iterations. Let's check exactly. Yes, 1 2 3 4 5 6 7 8, and then finally done. If at all if we want to use 0.1, then instead of using x is not equal to 1.0, we can use x is less than or equal to 1.0, or x is greater than or equal to 1.0 when we are using the floating point numbers. Okay, since we are using the floating point numbers, instead of using x is not equal to or equal to, we should use x is less than or equal to or greater than or equal to. So here we are replacing x is not equal to by less than or equal to 1.0. Once again we are using the same variable, that is x is equal to x plus 0.1 increment value. And let us check this program code, selecting and pressing F9. So look at here, 1.0, second iteration 1.1, third 0.2, fourth 0.3, 0, and then finally 4, fourth 0.4, fifth 0.5, 0.6, 0.7, 0.799, 0.899, 0.999. Look at here, 0.99999 is obviously nearly less than or equal to 1.0. The program, the condition becomes true as long as the x value is less than 1.0. Once 0.9999 has been taken place, means once the summation of the value becomes 0.9999, and the next moment the value will become greater than 1.0. When the value becomes greater than 1.0, the condition becomes false. When the condition becomes false, the loop will terminate, and finally we are printing the result. So here the logic is the program stops as soon as the floating point number becomes less than 1.0 with closely matched fractional floating point numbers. So in this program, the execution has stopped when the floating point number becomes 0.9999 because this value is matching the condition x is less than or equal to 1.0, and the condition becomes false as soon as the value reaches more than 0.999, and even 0.999 plus 0.1 becomes greater than 1.0, and the condition expression becomes false, and the while loop ends looping the code black, and finally the program ends with the message done. So this is how the logic works with the floating point numbers. So when using the floating point numbers, care must be taken to avoid infinite execution of the loop statements. So